Hello everyone, welcome to DS from scratch. In this video, I want to explain the linear regression from scratch, and we will do the gradient descent for finding the optimal weight and bias. So let's start with importing the libraries pandas, numpy, and matplotlib. So I'm using data from Kaggle. I have shared the link for the dataset. You can download from there also. And our dataset is TV marketing. Look, how much you do marketing and how much your sales will increase. So let's look at the data, how it looks. So this is the TV advertisement and how much is your sales has increased or decreased based on the TV advertisement and your sales. Okay, so first of all, let's divide the data into uh, into input and output. Okay, so let's say that input is equals to data TV, and your output, which is the target value, will be data sales. Okay, so let's first of all plot the data, how it looks, scatter. Okay, input and target. Okay, let's look at the data. So this is the data. In the x-axis we have the input values, which are the TV advertisement, how much you have spent on your TV advertisement. In the y-axis is your sales and how much your sales or the target value has increased or decreased. So for applying the functions, let's convert the data into numpy. Let's say input is equal to np dot array input. So when you are converting the data, it will give only one dimension. Okay, so it has one dimension. So for calculation, also for better using this data, we will add another axis, np dot new axis, so it will get another dimension, which is 1. Okay, 200 rows and 1 column. Similar to this we can do for the target values. Target is equal to np dot array target, and we will say that create one new axis, np dot new axis. Okay, so now the data is ready. In linear regression, as you know, that the equation for linear regression is equals to y is equals to a x plus b, or wx plus b, which is a is the weight and b is the bias. Okay, so we will be using this equation for linear regression. Okay, so let's say that y is our predicted value is equals to wx or w times input plus output plus bias. Okay, so we don't have any weight or bias. For that we have to initialize the weight value and bias value. We can say np dot once, or we can put 0 or any value. We can initiate any value. Okay, so the dimension should be input dot shape. Okay, based on the number of columns or the number of variables, we will get that many weight. Okay, number of columns should be 1, and the bias should be b is equals to np dot ones. Okay, 1 and 1, only one bias will be there. Okay, so this is the our equation. So for linear regression, the product of weight and weight to input is a dot product. In this particular example we can use this product, but if our dimension is higher than 1, then we will be using this np dot weight input and weight plus bias. Now let's look at the predicted value. So this is our predicted value y. Okay, so after getting the predicted value, what we have to do is we have to calculate the error. How much is our error? So based on the error we will decide to further improve the value of the w and bias or not. MSC is mean square error. So what is the error? The error is target minus predicted value. So as it is mean square error, so we have to take the square of the error. For taking the square of the error, we can say that square, and then for taking the mean value of the square error, we can say that np dot mean in parenthesis. Okay. So let's look at the MSC. Our MSC value is 25,322. So it is a very big number. So further, in the if our MSC is very huge number, then the code will crash. For avoiding this, we have to normalize our input values. Input is equals to, we will be using a normal normalization method, which is np minus minimum of input over, okay, uh, np dot max input minus np dot main input. Okay, so in here also we have to close the parenthesis. So after normalizing the input, let's look at the new MSC. Now the our MSC has came to the three digit number, okay, 184. So we can see that the MSC value is a very high value. How we will decide to decrease the MSC value? So for that we have a method which is called gradient descent method. So for gradient descent, like suppose this is your graph of this is your weight and this is your MSC value. Okay, as the MSC is the square, so the shape of the MSC will be like this. Okay, this will be the shape of MSC. So our goal for gradient descent method is to finding the minimum MSC and which corresponds to the that W. So for finding that, we will do gradient descent. So for we will find the slope of this. If the slope is minus, so we are going to towards the W. If the slope is negative, so it means that we are going far from W, and we have to minus those values from the W. Okay, so this is the gradient descent for W. For calculating the gradient descent, what we have to do, we have to take the derivative of the derivation of the MSC. Derivation of the MSC for respected to W is equals to, okay, minus 2 times NP dot product of input and error. Okay, target minus Y. Okay, and all the values over y dot shape 0. So how we got this? Like if you see the formula of the mean square error, it is like 1 over n. N is the number of samples. Okay, so this is your target value minus predicted value to the power of 2. If you do this d of this to the d of w, okay, what will you do? So our w is nothing but y x plus b. Okay, yx plus b. If you take the derivation, so the first derivation will be 2 times t minus y times, then we take the derivation of this portion, which will be minus x. Okay, so minus x over n, which is the number of the sample. So we did the same thing. We brought this negative signs to minus 2, then the x times t minus 1 np dot product of input values times error and to the power of divided by the number of the sample. So this is how we will calculate the gradient descent for W. For gradient descent of the B, only we will not calculate the x, we will only calculate the minus 2 sign. Okay, so this is the gradient for W, and gradient okay, gradient descent expected to B is equals to minus 2 times, okay, target minus w, and we will take the mean value of this np dot mean of this. Now let's look at grade w and grade b. Okay, w and grade b. Okay, invalid sign. So what is the problem here? Minus 2 times np dot np target. Okay, we have forgot one parenthesis to close the parenthesis. Okay, so this is again the problem is okay. Okay, so the shapes of input value is 201 and the shape of the error is 201. You know that the matrix calculation is not possible with this shape, so we have to transpose the input value. We can put dot p, which will give us the transpose of the input values. Okay, so now we have got the gradient for w and gradient for uh, bias. Okay, so after getting this, what we will do is we will update the b, we weight and bias. We can say w is equals to w minus, or can, or just simply can say w minus is equals to learning rate, learning learning rate times get w, and b minus is equals to learning learning rate times get b. Okay, so now let's look at our new w and b. So we have not specified the learning rate. Let's specify the learning rate. Learning rate is equals to 0.01. Suppose we are taking 0.01, or you can put any other number. Okay, so this is our new weight and bias. Okay, 1.14, 1.25. Now again, let's predict the our value, and again let's calculate the MSC. Okay, so we will take these values. Again, let's calculate the MSC, see how much the MSC has changed or not changed. Okay, you can see that MSC, our new value is 173, while the previous value was 181, so it has decreased by 8 units. Okay, so if we do this for higher iterations, then we will be getting the minimum MSC possible. Okay, so let's say that for I in range of, like, suppose we will be starting only with 100 values. Okay, with 100 values. So for the first iteration, what I need is I want the code to predict the value. Okay, for our initially initialized weight and bias. After that, I want the code to uh, give me the gradient for weight and for bias. Okay, so we will paste the gradient for weight and the gradient for bias code here. Then after getting the gradient for weight and gradient for bias, what I want to do is I want to update the weight and bias. Okay, I want to update the weight and bias. Okay, so here I have updated the weight and bias. So now after updating the weight and bias, again it will go to the next iteration. Again it will calculate. So I want to finally, after finishing the iteration, I want to get my MSC values, how much the MSC has decreased or increased. Okay, so now I think we are done with the code. Now let's look at the new MSC after 100 iterations. So now our MSC has decreased to 15. So it is a very huge like decrease from 173, or initially from 181. Okay. So now let's plot the figure for predicted, and first let's plot the scatter of the uh, values of input and target. Then let's plot a line of the uh, input and the predicted values. Okay, so let's give it a color of orange. So not mix between these two. So now this is the dots or the values for the input and the output, and this line is the regression line which we have taken using this equation. So you can see that the line hasn't fit well, so we what we can do is we can increase the iteration, okay, for 1000. Then again we will plot the line, then we will see how much it has changed. Okay, so now it has become 10. Now let's again plot. Now you can see that the line has fitted more better. Now let's again uh, run it for 1000 more, but this time the MSC has not changed much more. So let's run it again. So again that MSC is now in a stable point. So after this it means that the code won't the line won't fit much better than this. Okay, so this will be our final line. So now let's uh, compare our model with the model which is available from sklearn. We can import the linear regression algorithm from sklearn. From we can say from sklearn dot linear model import. We can say linear uh, regression. Okay, from sklearn. Okay. Okay, so we have successfully imported the linear regression. We can say that our model is equals to linear regression. Okay, so this is our model. Now we will say that model dot fit input and target. Okay, so let's see. Let's run the code. I think it has fitted the model to input and target. So now how we can compare it? Look, this model will give us two parameters, which is model dot coefficient, which is the W. Okay, we can just print it. Coefficient. Okay, so this is our W value. We can put it as W is equals to or W model, so we'll not mix with our W, and we can say bias model is equals to model dot intercept. Okay, so these two will give us the W and B. So when we have the W and B, what we will do is we can do Y rate, okay, or Y model is equals to W model or NP dot product of input and W model plus B model. Okay, so after getting the Y model, we can calculate the mean square error of new predicted Y. Okay, so instead of Y, we can put Y model. Now let's see how much is the MSC from sklearn. You can see that it is exactly the same MSC value as we have gotten from our own model, 10.51, and this is also 10.51. So we have written the exact same and a code which we can compare with sklearn, and it performs very well. So guys, this was the video about the linear regression from scratch. I will be providing the link for this notebook, and also I have prepared a video which shows how the lines will fit using for different iterations. So like suppose for first iteration, for second iteration, where will be the line? So the line will be starting from here, then it will go here, then it will change the slope of the line and the intercept of the line. So please check that video. Also it will help you understand how the line fits well. So thank you for following this video. Please don't forget to like and subscribe.